Hey, sixth graders. Today we're going to go ahead and start analyzing data sets. And data sets are just sets of numbers that can represent anything, really. We could have a data set on temperatures, average temperatures for a week, or we could be comparing heights, or we could be comparing grades or scores of if we wanted to take a look at Mason Prep's ERB scores, we could look at that entire data set. So, oops. I'm gonna, so we have a couple of different ways that we can describe data sets, because when we have this whole long list of numbers, it can be really hard to conceptualize and it can be hard to understand. So we have a couple of these different descriptors or descriptions for our data sets that give us a really good idea of what types of numbers we're looking at. So one of the most commonly used measure of our data is what we call the mean or the average. The mean is the technical term, but you'll always hear people call it the average. If you've ever, if you turn on the news, I guarantee you every single newscast, you hear the word average, like the average American gets 8 hours of sleep per night. It is a very popular measure of our data. And so what it is it's the sum of all of the data. It's the sum, which is going to be addition, of all of the data divided by the number of pieces of data that we're dealing with. So it's a couple of very easy steps. So step one, what we're going to do is we're going to add up all of our data points. The next thing is we're going to divide that sum by the number of pieces of data that we have. And then that is going to be our average. And what the average describes is kind of like, what is that middle temperature? What is the middle height? So let's go ahead and do a couple of examples to make sense out of this. So if I'm going to find the mean temperature, I'm going to be finding the average temperature. And so what I'm going to do is I'm going to add all of these up, and then I'm going to divide by 1, 2, 3, 4, 5, because I have 5 pieces of data. So let's go ahead and add those up. Uh, 9 plus 3 is 12, plus 5 is 17, plus 8 is 25, and that's 14, plus 6 is 20, plus 2 is 22, plus 3 is 25, plus 6 is 31. So it's 315 is our sum. Now we need to take this and we're going to need to divide it by 5. Now, I'm sorry, I'm getting ahead of myself. I don't normally set our problems up like this. I normally will write it horizontally. Plus 35 plus 68, all divided by, with a massive fraction bar, 5. So now what we're going to do, because that is going to be equal to 315 divided by 5, now we're going to go ahead and divide. Let's see, what do we get? 63. So 63 is our average temperature, which means 63 degrees is falling in the middle of all of these temperatures. And as you can see, that 35 is pretty low. I would call that an outlier, which we're going to talk about in a little bit. That definitely kind of drags down that middle piece of data right there. Let's do another example. Let's find the mean height. So what we're going to do, again, we're going to go ahead and add up all of these pieces of data, and then we're going to divide by 1, 2, 3, 4, 5, 6 this time. So you have 62 plus 67 plus 64 plus 65 plus 59 plus 67, all divided by 6, because I have 6 pieces of data. Just off the bat, I'm going to go ahead. I anticipate that our average is going to be somewhere in the maybe like 63 or 64, because I have 2 67s and my lowest is 59. So I know I'm going to be falling between those data points, and it seems like it's probably going to be like 63 or 64. I'm not entirely sure what it'll be, so let's figure that out. Now I'll go ahead and stack these horizontally, or excuse me, vertically, so that we can go ahead and add them. Let's see. So I have nice groupings of numbers. That's 9 plus 9 is 18, plus 7 is 25, plus 2 is 27, plus 7 is 34. 1, 2, 3, 4. I have 5 sets of 6, so that's 30, 35, 38. So this is 384 over 6. And let's go ahead and divide. So I'll just kind of set it up over here. 384 divided by 6. That goes in, 6 times. Minus 36. That's 2. 64. So 64 is that average height. I'm going to go ahead and let you figure out that last one on your own. Hey, absolutely.
Thank you.
All right, so let's go ahead and flip over and take a look at a couple other ways that we can describe our data. So we can use the median and the mode. So the median of a list of values is the value appearing at the center or middle of that sorted list. So the first thing we need to do is to actually sort the list, and we sort it in order from least to greatest. And then we're going to do what I call ninja work, and we're going to be crossing out numbers from the outsides in, and we're going to be crossing out the smallest and biggest one, working our way into the middle of the list. So we're going to cross out values on either side, working our way into the middle, working your way into the middle until you've determined that central value. Here's the toughest part about this, and it's really not that tough at all. If there are 2 numbers in the center, if you are left with 2 numbers, you need to take the average or the mean of those 2 numbers in order to figure out what that median would be. So let's do some examples. So let's go ahead and we're going to first list this order from least to greatest. So I have 2, 3, and I like to cross them out as I go to make sure I got every single number. 5, 6, 6, and 9. Okay, got all of them. Now I'm going to do that ninja work, and I'm going to start crossing out numbers until I've worked my way into the middle. So outside, outside, I work my way in, boom, boom. So this is my median. All right, let's do another example where maybe we have 2 numbers that are left in the middle. So I'm going to order this from least to greatest. So I have 5, 6, 6, 7, 13, and 13. Let's do that ninja work again. We're going to work our way in. Ooh, so I have 2 numbers here. So what we need to do is we need to take the average. Now, some of you guys could do this mentally. This one's not bad, but if I gave you nastier numbers, like let's say 26 and 37 were left in the middle, what we're going to do here is we're going to take the average. So we're going to do 6 plus 7, and we're going to divide that by 2. So that's 13 divided by 2, which is 6.5. So you can do 6.5 or 6.5. So our median would be 6.5. And then another way that we can describe our data, which I think is the least useful and the least used, but it still exists nonetheless, is called the mode. And that is what shows up the most often. And the way I used to remember it was mode, M-O, and it's a 4-letter word, most, M-O, mode and most. So there's no sorting at all. You're just literally looking for the number that shows up the most. Sometimes there is no mode, and sometimes you might have more than one. So let's see, I've got 1, 15, 9, 12, 18, 9, 5. Okay, 9 showed up twice, so my mode is 9. Let's see here, 17, 7s are showing up, oopsies, 3 times. So my mode here is 7. Let's see down here, I've got 2 9s and 2 4s and 2 3s. So I would just go, oh, no, I have 3 3s, so that's the winner. So the mode is 3. And then here, let's see, 18 shows up twice, 25 shows up twice, 14 shows up twice. Yeah, so look, oh, 25 shows up 3 times. Keep getting a little tricked there. So mode here is 25. All right, be sure to tune in to the next video on another way that we can measure our data, and it's called measures of variation. So again, all of these describe the center of the data. Now, this doesn't necessarily describe the center of the data, because especially if you look here, if 27 wasn't there, 25 is not really it's definitely not in the middle of our data. That would be the biggest point. So it's interesting that mode falls under a measure of center. I don't usually consider it a description of the center of our data, but median definitely describes the middle, as does your average or the mean.